Greetings. I am Jeannette Wing, Evanescence Director of the Data Science Institute at Columbia University. Welcome to Data Science Day 2020. More than 1,800 people from around the world have registered for today's virtual event. We are pleased that you have taken the time to join us. Data Science Day is the Data Science Institute's flagship event and an annual opportunity to host thought leaders and showcase data-driven research across Columbia. Today's theme, Ethics and Privacy, Terms of Usage, has allowed us to convene subject matter experts who are driving discussions on ethics and privacy in data science. Why ethics and privacy? Data science as a new emerging technical field with profound societal consequences requires us to face these issues head-on from the very beginning. Data science raises new ethical issues. The ethical principle of respect for persons suggests that people should always be informed when they are talking with a chatbot. The ethical principle of beneficence requires a risk-benefit analysis on the decision a self-driving car makes on whom not to harm. The ethical principle of justice requires us to ensure the fairness of risk assessment tools in the court system and automated decision systems used in hiring. What new ethical principles does data science raise? At Columbia, we take data ethics seriously for our students and in our research. Regarding privacy, much of the success of today's data science methods, such as deep learning, relies on having lots and lots of data. The more data, the better the model. And that data today is typically data about people, data about us. So how can we build models and systems that use these models while preserving the privacy of our data? A timely example is building a COVID-19 contact tracing app, where we need to balance privacy and public health. Another timely example is Census 2020's use of differential privacy to reduce the risk of disclosing an individual's identity from publicly released statistics. The data science community, including at Columbia, is in the midst of exploring practical, scalable technologies to share data while preserving privacy. Today's speakers will cover a range of topics, including ensuring the responsible use of data, exposing algorithmic bias, and the benefits and risks of data sharing. I hope the lightning talks, keynote address by Eric Schmidt, and fireside chat will be inspiring and thought-provoking for you. I would like to take a moment to acknowledge and thank our industry partners for their ongoing support of the Data Science Institute's research, education, and outreach programs. We appreciate your continued engagement with our unique community. Now, I'd like to introduce Tamar, Data Science Institute faculty member and assistant professor in the School of International Public Affairs, who will moderate our lightning talks.
Hello, everyone. It's an honor to be here today. We have an exciting line of speakers from various departments at Columbia University speaking about the intersection of human rights and artificial intelligence, the economic effects of the EU's General Data Protection Regulation, the ethics of using data science in public health, and how to promote privacy in machine learning models that increasingly draw on personal information. Our first speaker today would be Rafael Yuste. He's a professor at the Department of Biological Sciences in the Faculty of Arts and Science at Columbia University.
Good morning. I'm going to be talking to you about neurotechnology and specifically about the role that neurotechnology will have in the future of humanity and how we should be concerned about it and we should make sure that we set out a path which is ethical and consistent with societal values. So all of this starts in 2013 when President Obama launches the US Brain Initiative. This is a large-scale scientific project that involves more than 500 labs around the country and the world today. It's supposed to last 15 years, estimated budget of $6 billion. And the purpose of this is to develop neurotechnology. What is neurotechnology? New methods, new tools to perform three goals. One is to measure the activity of every neuron in the brain. The second is to be able to activate and manipulate the activity of every neuron in the brain. And the third goal is to computationally analyze this data with novel software and mathematical tools. Taking after the Human Genome Project, its older brother, the US Brain Initiative, is progressing by building these tools to analyze in their completeness the nervous system of small animals, that would be like worms and invertebrates, and then graduating through flies, fishes, eventually getting to mammals like mouse and the human brain. So the US Brain Initiative is not alone. In fact, the Brain Initiative has spurred the creation of similar brain initiatives throughout the world. So we now have brain initiatives in China, in Japan, in Korea, Australia, Canada, Israel, and the European Union. So we're actually, since last year, we've formed a global brain initiative, the International Brain Initiative. So we're talking about a revolution in the tool building for neuroscience. And this is going to be fantastic. There are three main benefits. One is for science. With this tool, we'll be able to finally understand how the world works. And the brain, as you know, builds our minds. So by understanding how the brain works, we'll understand ourselves for the first time from the inside scientifically. The second reason why this is important has to do with the clinic. As you know from personal experience with family members or friends, neurological and mental diseases have no cure. And the reason for that is because we don't understand how the brain works. So it's just like a car. You need to figure out how it works in order to be able to fix it. The third reason has to do with the economy. So neurotechnology, just like the Human Genome Project before it, could launch the opening of a new type of enterprise, neurotechnology, neurotech, that could revolutionize computer technology and the tech industry. This is all wonderful, but let me remind you that the brain generates the mind. So if we're able to go in with our tools and read the activity of brain circuits and manipulate or modulate the activity of brain circuits, we're actually reading mental processes and manipulating mental processes. So we have to be very concerned about how these tools, which are very necessary for the future of humanity, how they get applied to the population. And because of that, a group of us, 25 people that are coming from neurotechnology, representing all the brain initiatives from throughout the world, representing the tech industry, neurotechnology industry, the clinic, bioethicists. We hold ourselves together here in this building at Columbia University, and we proposed in 2017 4 ethical priorities for neurotechnology and AI. We think that we're dealing with a problem that has to do, impacts the human rights. And we coined the term NeuroRights as new human rights that you can imagine be cerebral rights that we think should be added to the Universal Declaration of Human Rights, which is written in the wall of this museum in Chile, Museo de la Memoria in Santiago. So the new human rights would be the right to mental privacy, the right to our own identity, to ourselves, the right to our own free will, our agency, the right to have equal access to cognitive and mental augmentation, and finally, the protection from bias and discrimination. So to pursue this agenda, we've created a group of people here at Columbia, the NeuroRights Initiative, and for the last couple of years, we're involved in pushing this agenda in 3 different directions. The first direction is a protective direction, a defensive path, and this is to implement legislative protection for neural rights. We're working with different countries, with Chile, with Spain, with the European Commission, with Kenya, and in Chile, we're very far. We are in the process of putting in a constitutional amendment to the Chilean constitution. Here's supported by the president, the Minister of Science, and the leader of the Senate, and also a new bill and before the Senate, the NeuroRights bill that would establish for the first time legally concepts such as neurotechnology, brain-computer interfaces, NeuroRights, defines neurodata as a body organ, and proposes a medical model for the use of non-invasive brain-computer interfaces. It's a defensive maneuver. We're also more proactive, and we have the proposal of a technocratic oath for the tech industry. The idea is something very similar to what happens in medicine, where every medical doctor, including myself, when we graduated, we took a personal oath, a Hippocratic oath, of using our knowledge for the benefit of mankind, of humankind. We think the tech industry is ready for this, and we're proposing a tech oath based on 4 principles: the principle of beneficence, do good; principle of justice, treat everyone equally; principle of dignity, respect human dignity; and then principle of transparency. This technocratic oath has been pioneered in Spain, the Basque Country, and also in Chile. And this is one colleague of mine who has an AI company, Uribe Echevarria, in the Basque Country and in Silicon Valley, who's adopting this technocratic oath. And finally, a third approach, strictly a technical approach. So this is just working with engineers and with experts, in this case with George Ripsack from our medical bioinformatics unit at Columbia. And the idea is to come up with algorithms that prevent these problems by treating neural data taken by neurotechnology, in ways in which we don't need to worry about issues like privacy, because that data would not be shared. So this is a case of using federated learning, for example, where the data doesn't leave the device, or when data is shared, that is shared according to a data-sensitive hierarchy, where every different type of data gets a label that determines how sensitive it is in terms of privacy. So we're exploring concepts like data sensitivity hierarchy and privacy, data differential privacy. And I finish also with an invitation to all of you to join us on November 19th on an online symposium on brain-computer interfaces, which are the heart of this neurotechnology. The brain-computer interfaces are the devices that connect the human brain to the net. And this is a symposium that's sponsored both by the DSI at Columbia and IBM. And we've lined up world experts on this technology, and we're going to be looking at both the technical hardware development of this technology, the data, software treatment of this data, and also issues that have to do with the ethics and societal applications. Thanks a lot.
Thank you so much, Rafael. Our next speaker would be Yeon-Koo. He's a Kelvin J. Lancaster Professor of Economic Theory in the Department of Economics at Columbia University.
Hello, good morning. It is a pleasure to be here. So I'm going to today talk about the effect of data privacy regulation on the data industry. This is a joint work with Guy Arider at Columbia University and Tobias Salz at MIT. So the fundamental tension at the heart of data privacy regulation is, on the one hand, consumers have fear and anxiety over firms collecting data and using the data for them. And firm consumers want more control over the data firms collect on them. On the other hand, on the firm side, firms are increasingly reliant on consumer-generated data, which is crucial for the machine learning technologies that they are using, as well as for targeted advertising, which generates much of their revenue. So in this paper, we looked at European Union's general data protection regulation, particularly focusing on the consent aspect of the legislation, which gives more control to consumers on the data firms can collect on them. And then we are trying to say empirically on the tension that you mentioned by first asking on the consumer side, do consumers actually make use of privacy means provided by GDPR? So consumers may say that they care about privacy, but do they actually act on their concern when given the opportunity to use this more powerful privacy means? And on the firm side, how does GDPR impact firms' access to consumer data, and how does it impact their ability to predict consumer behavior and accrue advertising revenues? So the data has been provided from a third-party intermediary in the online travel industry that spans much of the industry around the world. This data set is ideal for us because, first of all, the data collected by this intermediary is subject to GDPR consent requirement, meaning that the consumers can freely choose to opt out of the data collection by this firm. And then the primary business model of this firm is to collect user histories in terms of search and purchase, and predict whether or not consumers will purchase a flight or a hotel when they come visit on the website next time, and use this prediction to place advertising, which generates much of the revenue for this firm. So the empirical strategy that we use is a standard tool in economics known as difference in differences, which will allow us to get at the causal impact of GDPR. The treatment group for us are the travel agencies in European Union countries, and the control group are the travel agencies in non-EU countries, such as US, Canada, and Russia. And the data covers a period about 6 weeks prior to GDPR, which was implemented on May 25th, 2018, and it goes until 7 weeks after GDPR. And what we do is estimate how GDPR impacted the treatment group differentially relative to the control group in terms of what we care to know about. And first thing that we wanted to know about is the opt-out. Okay, how many consumers opted out after GDPR? Well, we do not directly observe opt-out, but we can actually compare the number of users before and after GDPR to get at opt-out. We can do so by looking at the number of unique cookies or searches. And as you can see here, there is a precipitous drop on week 22, which is exactly the week of GDPR implementation. And the drop is permanent, and it's about 10 to 12%. Okay, so what it shows is that the number of consumers actually did make use of GDPR privacy means. The next thing that we look at is the composition of remaining users. So we ask clearly, are there any changes in the composition, meaning that the consumers that are remaining after GDPR, namely those who chose not to opt out, any different from the consumers who are around before GDPR? In particular, we focus on the firm's ability to persistently identify or track consumers or their cookies, and basically look at, over all the cookies that this firm can observe, so that we can observe in a particular week what fraction of those guys are still observable 1 week later, 2 weeks later, and 3 weeks later, and so forth. And interestingly, and perhaps a bit surprisingly, okay, there is actually an increase in the persistent identifiability of consumers after GDPR. So we may wonder what's going on here. And the mechanism we think that can explain this has to do with the ways consumers protect their privacy before and after GDPR. So before GDPR, those consumers who are privacy conscious will probably delete cookies or use private viewing to protect their privacy. And if they do that, then when they come on the website next time, they are simply assigned new identifiers. So there will be a lot of artificially generated identifiers and histories of very short history of searches. And the presence of these guys confound not only understanding about these consumers who opt out, obviously, who protect themselves, but also the other consumers who choose not to obfuscate their privacy, obfuscate their visits. But those consumers who will be obfuscating before GDPR, now after GDPR, they will simply opt out, and if they opt out, they will simply disappear from the intermediary's database. So what we think is going on is that after GDPR, these guys will disappear from the database, so that there will be fewer users, but the remaining users are more trackable because we got rid of a lot of short histories of searches. So in terms of revenue, you can see that the revenue is basically generated from advertising for this firm, and there is actually a decline of revenue about 10 to 12%, and which we can explain directly from opt-out. But interestingly, the average bid for consumer ad click actually has steadily increasing after GDPR, and we think that this is consistent with the fact that consumers became more persistently trackable, which helped the advertisers to attribute purchase histories to ad clicks. So to conclude, you might wonder who wins and who loses from this regulation. The consumers who are conscious about privacy were definitely the winners because they have access to more effective privacy means. The other consumers are interesting because they became more persistently trackable when they choose not to opt out. And that raises a question about what happened to their welfare, and their welfare will depend upon how firms can use their improved ability to predict consumers. If they use it to benefit consumers will benefit. If they use to charge high price, consumers will be worse off. And finally, on the firm side, they obviously lose out of consumers opting out. But then there is a sense in which that the remaining consumers are more easily identifiable, more easier to predict. And so therefore, and then the value of these consumers to advertisers might have gone up. So their loss from opt-out would have been mitigated to a large extent. And I think this is all I have. Thank you.
Thank you so much, Yeon-Koo. The next speaker we have today is Jeff Goldsmith. He's an associate professor at the Department of Biostatistics at Columbia University's Mailman School of Public Health.
Great. Good morning, everyone. It's a pleasure to be here. I'm looking forward to talking with you a little bit about the perspective that I have developed in doing public health data science. I guess I want to start with a couple of disclaimers. The first is that although I'm going to be talking about ethics, I am not myself an ethicist, and I think that this is an area where we as a data science community would do well to engage with those who have grappled with these questions for a very long time. The other disclaimer that I'm going to make is that rather than talking about a specific project that I've worked on, I want to talk a little bit more about the general perspective that I have on working with data in what I hope is an ethical way. And to give some idea of what that perspective is, as I was introduced, I'm a biostatistician who works in a school of public health. I suppose now I'm a public health data scientist, but even before data science had gained traction, folks in the public health community have been grappling with questions about how to work with data in an ethical way for a very long time. And I think a big part of that comes from the idea that all of the work that I do and all of the work that many people in public health do is inherently human subjects research, that there's no sort of hiding the fact that the data that we work on come from people. And so I guess there are 2 points here that I want to drive home when I emphasize human subjects research. The first, as I say, is that data points in a spreadsheet represent people, and not to be overly melodramatic, but these represent health outcomes, that zeros and ones can often literally mean success or failure is life or death. And I think that conveys a sense of gravity and responsibility that gets carried through in whatever work that you're doing. The other piece of this in doing human subjects research is that the public impact of that work should ideally be clear. And what I mean to that is when health-related research is conveyed to the public, often there is a visceral identification, even among people who are not data scientists, a recognition of the work that is done as it relates to health as having some impact on the life and health and well-being of individuals who exist in a population. And I'll return to that point in a few minutes. I'm also going to mention that a lot of the work that I do relies on observational data. We do interact with clinicians and do randomized controlled trials, but a lot of the work that I do comes from situations where you are not able to randomize a person to one group or another. Now, I want to dwell a little bit more on this idea of human subjects research. Both Rafa in the first talk in this lightning round and also Jeannette in her introductory remarks touched on elements that are related to the Belmont Report. And these things have to do with respect for persons, beneficence, and justice. And what is important here is that this collection of guidelines, this collection of principles, has both been ingrained in a public health perspective for many years, since 1979 when it was drafted, and also has very clear implications for how one might do research. That is, respect for person includes both things like informed consent and privacy, but also a sense of empathy for the individuals who are engaged in that research, who have volunteered their time, their well-being, to convey some information, to have empathy with the people who you are working with. A goal to not just do good, but also to not do harm, that there's both an active stance and a intention that the work that you're doing is going to create some benefit. And then justice in the sense that all research conveys some benefits, ideally, but also carries some costs. And those should be thought of in advance and distributed in a way that is both respectful of persons and also just in some sense. A big part of the reason that the Belmont report was written is to solidify these things and also confirm that whatever research is done on human subjects is subject to some external oversight, that there is not an individual who is able to decide unilaterally what is fair and just and what carries respect for persons, but that there is some oversight, some external board that can weigh in on these topics. Now, I also want to pivot a bit to think about observational data, and here the same human subjects considerations, the idea that folks who are engaged in some study, observational or randomized, that they should consent to being in that study, that they should understand the risks, that they should be informed. All of the same human subject considerations apply, but observational data, I think, carry a couple of additional considerations. The first is that the data that you have in your hand are often not the data that you actually want to have. And then second, that the questions about causation are hard to address, but also critical to get right. And I do think that both of these are ethical considerations in the sense that understanding who you have access to, what data you are able to gather, can impact the kinds of results that whatever algorithm or analysis you apply generates. That understanding the imperfections of your data has implications for the results that you obtain, and it's your obligation to understand both what those are and what the impacts are going to be. An example that I like to bring up here that does come from public health is from many years ago now, is whether or not smoking causes cancer. To ask whether or not smoking causes cancer, you have to understand first, well, how do you measure what it is you want to obtain? How do you measure smoking? How do you identify cases of cancer? And once you have identified those as inputs that you are interested in, how do you measure them? Who responds? What are the differential response rates in a population? Who smokes and who doesn't? And who would you like to draw inference on, and who are you able to draw inference on? All of those things, I think, come together. The limitations in data in a very simple to pose question, does smoking cause cancer? The implications in how to obtain that data and the limitations of data that you might obtain, I think, again, drive the kinds of conclusions that you might be able to make. And then causal questions are not something that I'm going to get into too much now. I think everybody is sort of familiar with the idea that correlation isn't causation, but I sort of like this response that correlation isn't causation, but it's not causation either, and that you very much have to spend some amount of time understanding what causal implications some analysis is making, what causal claims you are making, whether or not you are able to sort of substantiate those in a real sense. So again, I want to sort of think about the perspective that I have, and what I'm going to do now is make a couple of recommendations. And the first of those is to take a very, very broad view of human subjects' work. In her opening remarks, Jeannette referred to things like self-driving cars, and I would build on that by saying that there are some recent, I think, very public missteps that clarify the extent to which human subjects' work underlies a lot of data science. One that I'll point to in particular are recommendation systems and things like Facebook and YouTube and Twitter, things that operate on people, but that have recently become understood to drive potentially sources of radicalization. And so here, the point that I would make is that data comes from human, and the results matter to humans. They change behavior in a way that people react to viscerally in the way that they react to health information. The second recommendation that I would make is to ask hard questions about your data. Who is included, and what will your approach find as a result? The biases that get baked into, or that that exist in data and then get baked into the results of some algorithms appear in places like differential predictions, differential racial predictions, differences in prediction accuracy across racial groups in the context of health and medicine. And then the final thing that I'm going to recommend is to involve stakeholders and plan for dialogue. And this is a little bit different from interdisciplinary research in the sense that it is not so much a question of getting other scientists on board, but planning for the idea that there will be public reaction and that stakeholders should be involved in this. And without going into too many details, I would sort of remind people of the perennial debates that come up anytime there is a new recommendation around cancer screening, that's not simply a question of true and false positive rates, but a question of risk tolerance, who is affected and how and why. And so those are sort of the three recommendations that I would make to data scientists outside of public health based on my perspective. And I appreciate your time very much. Thank you.
Thank you so much, Jeff. Our next speaker is Roxana Jimbasso. She's an associate professor at the Department of Computer Science at Columbia University.
Thank you very much, Tamar. I want to use my lightning talk to disseminate the basics and, to some degree, our contributions to differential privacy, a technology that I think is very important for any data scientist to be aware of, especially if you're dealing with sensitive user information. Here's the general setting for differential privacy. You collect some data that is of personal nature, for example, records of a user's activities or purchases. And you want to analyze this data to extract statistical insights, such as statistics about the population or machine learning models. And you want to share these insights with your partners or clients. Yet, you're concerned about the privacy implications for users whose data you collect. The question that differential privacy answers is, how do you know what kind of statistical information is safe to share and how much of it is safe to share? For example, is it safe to share the average dollar value purchases for people in a region? Well, you may say it depends on how big the region is. If it's really small, like one person lives there, then no. But if it's a big region, then maybe sharing the average is okay. But what is big here to be safe to share this average without incurring the risk of exposing individual purchases? It's unclear, and it actually depends on how much other information exists out there about purchases in this region. In fact, there is a famous theoretical result by Irit Dinur and Kobi Nissim that states that releasing too many statistics of many kinds, not just averages, from a dataset fundamentally enables reconstruction of that dataset. And I'd like to go with you through an example of data reconstruction so you can really understand the privacy threat involved in sharing statistical information around. Every decade, the Census Bureau collects demographic information about individuals in the US. They release numerous contingency tables at various geographic granularities. For example, tables of the number of people of a particular race, of a particular age, and so on. In 2018, the Census Bureau studied the potential for reconstruction of the 2010 census database from these released statistics. Their idea was to find a database that was consistent with the many counts that were released back in 2010. This can be formulated essentially as a big system of linear equations that you have to solve. And there are solvers that can do that automatically for you, given enough compute power. So what the Census Bureau did was to hire a lot of compute cycles from Amazon, and they managed to find a solution. And they used that solution in combination with some commercial databases to first de-anonymize a significant fraction of the US population based on their sex, age, and city block, and second, to recover the declared gender and ethnicity for those de-anonymized people. And they arrived at the conclusion that for 52 million Americans, they can do that successfully. So that's a privacy leak that we now know resulted from the 2010 census. And it led to the census adopting differential privacy for 2020. Now, this kind of data reconstruction procedure can be applied to many other types of statistical information, not just counts. In fact, similar kinds of attacks have been demonstrated against complex machine learning models, such as deep neural networks, which have been shown to expose individual entries in their training sets through predictions or model parameters. So take note if you plan to share models around. The de facto remedy for this kind of privacy exposure is differential privacy. This is a theory that lets us reason about how much statistical information and how accurate is safe to share under a very strong adversarial model. It works regardless of what the adversary already knows about the dataset and how much compute power he has. Essentially, differential privacy randomizes a statistical analysis, such as the process of training the machine learning model, to ensure that no individual entry in the database has significant effect on the distribution over the outputs of this randomized statistical analysis. That's essentially what that formula at the bottom says. At a more intuitive level, here's a good way to think about differential privacy. Suppose your company wants to collect data from users, compute various statistics and models on that data, and then share those with partners or clients. If the process by which you produce these statistics and models is differentially private, then you can guarantee to users who agree to participate in your statistical analysis, that is, they click yes in your terms of service, you can guarantee to them that their privacy risk will not increase by more than some small factor compared to if they had chosen no in your privacy risk, in your terms of service. A few words about the state of research and development of this technology. First, differential privacy, I believe, is quite mature at this point on the algorithmic side. There are differentially private versions that are known for most popular statistical analysis algorithms, including machine learning training algorithms. Where, in my opinion, there is still a big gap is on systems that operationalize differential privacy. That is, they address its programmability, testing, and deployment challenges. My group at Columbia is one of the few working on this topic. And there isn't time to go into the deep technical details about what we're doing, but basically, we are incorporating differential privacy into real infrastructure systems like TensorFlow, Kubeflow, and Kubernetes, really creating the systems infrastructure needed for privacy-preserving data analysis and sharing. And we're applying these infrastructure systems to the real world through several collaborations, including with the Columbia Medical School and with the Brookhaven National Lab. In the former, we are training differentially private models over clinical data from the New York Presbyterian and using those models to enhance drug safety studies on FDA's adverse reaction database. This database is very valuable because it aggregates adverse reports from medical providers all around the world. But it's heavily redacted by the FDA before making it public to eliminate any personal information for obvious privacy reasons. For example, records lack the medical context of a patient who exhibited an adverse event. But of course, medical context is often a confounder for adverse events. So drug safety researchers cannot possibly rely only on the FDA data alone in their studies. They need access to good, large clinical data too, which limits who can run these kinds of studies. Well, in preliminary experiments, we've seen that by training a machine learning model on clinical data from the Presbyterian and using that model to impute the missing clinical context in the FDA dataset, we can reduce the confounding effects to basically the baseline. And we're training the New York Presbyterian model differentially privately so that we can eventually safely release the model to enable drug safety, any drug safety researcher out there to deconfound their studies on the FDA dataset. One last point to make in closing. Even if you don't care about privacy, you should still be aware, in my opinion, of differential privacy because it's been connected by ourselves and by others with several other desirable properties for statistical data analysis, including fairness, generalization, stability, and robustness to attacks. So, if you care about any of these other properties, I encourage you to consider differential privacy and randomization as basis for your solution. Thank you.
Thank you so much. Now we're going to go to a Q&A session where we have questions from the audience for our four speakers. So The first question that we got from the audience is that how do we know companies take opting out consumers off their tracking lists? How do we know companies do not use alternate ways to track opting out users using other methods? This is relevant for a bunch of you, but whoever wants to go first.
So perhaps I should begin. So I do not. There are two sides to this question. One is that the enforcement side of this consent requirement. So if somebody choose to opt out of the data collection, is that wish honored and respected, and the rule is therefore enforced. And as far as I am concerned, that the system is set up to ensure that the opting out wishes are respected. But more interesting question is that are there any other means for making predictions of consumer behavior? And the answer is definitely true. I mean, so for instance, Google has been moving toward the evolution of tracking consumer cookies. But that doesn't mean that they don't have any other ways of actually predicting consumer behavior. So one has to be vigilant and careful about the fact that there are other ways usually to predict consumer behavior, and therefore compromise privacy.
Thank you. Would any other speaker would like to answer the question before we go to the next one?
I may add, I believe that there is a great need for infrastructure that audits these kinds of policies and their enforcement, automated infrastructure. We've done some work a few years ago on experiments. Essentially, we're doing experiments against particularly Google services, but you can do this for any other kinds of services, where we track how user data is being used for targeting. And such, and essentially we do correlation between the actions that users do versus the ads that they see. And that kind of infrastructure, I think, is really needed so that we can be able to track and expose if there are any web services that don't actually enforce these kinds of policies that they say they do.
Great. I believe we have more questions coming up. So our next question is for Rafael Yuste. How will the NeuroRights initiative align with data ethics initiatives, example the FATES, in practice?
So our angle, we're coming straight from neurotechnology into the middle of data science and AI. So we're in the process of building coalitions. In fact, I just spoke at the Global Data Summit last week, and we haven't yet interacted with this initiative, but we'll be very eager to do so. They can find us on the web, NeuroRights Initiative, and we're open for business. In fact, this symposium that we're holding on November 19th here at Columbia has people coming from the tech industry, from academia, and as well from people with backgrounds in all kinds of fields. So I think what we need is a broad coalition to really tackle this problem together.
Thank you so much. Do we have any other questions from the audience before we move on? Okay, so now we have a little bit more broader question. So since data flows can easily cross borders, how can we ensure that privacy and personal data are protected globally? Perhaps Jeff could answer this question first.
Yeah, so I think there are a couple of reasonable things that ought to be considered in this question. And the first is a technical solution. I think potentially some of the things that Roxana talked about or extensions of those might be reasonable technical solutions to do things like ensuring privacy. But I think there are also cultural solutions to these things. And I think the cultural solutions that I think of have to do with the extent to which ethical practices are instilled in data scientists working in companies internationally, right? That it's not just a question of can we address technical issues that prevent the flow of data? Do we, as a data science community, have a code of ethics that would preclude that from sort of like a practices standpoint, not just a technical standpoint?
Thank you so much. I really appreciate you coming here today. And we're going to move to the next section.
It is a pleasure to introduce Eric Schmidt, who will deliver today's keynote address, which will be followed by a fireside chat and questions from the audience. Eric and I have known each other since our graduate student days, and we have both witnessed the rapid advances in computing technology over the decades. Eric is an accomplished technologist, entrepreneur, philanthropist, and a New York Times bestselling author. He is co-founder of Schmidt Futures, which helps exceptional people do more for others by applying science and technology thoughtfully and collaborating across fields. Eric pioneered Google's transformation from a Silicon Valley startup to a global leader in technology. He served as Chief Executive Officer and Chairman from 2001 to 2011, Executive Chairman from 2011 to 2018, and most recently as Technical Advisor. His philanthropic efforts through the Schmidt Family Foundation focus on climate change, education, and cutting-edge research and technology in natural sciences and engineering. In May, Eric and Schmidt Futures were selected by Governor Cuomo's to lead New York State's Blue Ribbon Commission, which will employ lessons learned from the COVID-19 pandemic to improve and modernize state systems for the future. And now, our Data Science Day 2020 keynote speaker, Eric Schmidt.
Thank you very, very much, Jeannette. You know, it's interesting that when we were graduate students, my basic problem in life was keeping up with you because you were so much faster than I was. And so congratulations to you and what you guys have done at Columbia. I've been thinking a lot about tech optimism. I spent 40 plus years believing that technology was a strong force of good. And I must say, I get angry when the reality of the world collides with my relatively naive and simplistic view that technology should just make people better. And what I think is happening now in tech is that not only is my naivete been replaced by hardcore realism, but universities like Columbia are trying very hard to develop a broader and deeper understanding of where the technology really affects people. There are obvious examples where my technology optimism, which is embedded in the ethos of the tech industry, the tech founders, they believe that they're making the place a better world, and so forth and so on, runs into the reality of how their technologies are used. As an aside, and before we talk about data, open source is the most obvious such example. We all believe in open source. Open source is profoundly powerful and is the basis for much of what we do. But remember that open source means the people that you don't like get access to it as well, right? And I don't think we have collectively, as a community and as computer scientists, come to sort of a proper conversation about that. In other words, is there any reasonable limitation that you should put on open source and, in fact, on research in our space? Maybe because we're too new, maybe because really terrible things have not happened. But I think what you're trying to do in data science and ethics is an example of trying to deal with a very hard problem. And so the most obvious example to start with is what's going on in China. And I think I can just state that people are familiar with the concept of a panopticon, a prison that was organized around surveillance 100 years ago. And China has now managed to unify the problems of mobility, commerce, identity, location, all in your mobile phone. My last trip in China, my friends had never used cash, and the crime rate was very low. And they viewed the rules around their phone and their identity, and they said this honestly to me, as a net positive, right? Whereas I suspect the vast majority of the people in our audience, and certainly at Columbia and in New York City, would find them unacceptable. So we have to think a little bit about what we're doing and how we end up with the sort of right balance. And one way to intellectually say this is that control over personal data is more of a novel type of right. Right. So your intuitive answer is I should control my own data. And so I'll give you an example. And the simple one is that your phone knows where you are for E911 services. So should you be able to suppress that? You discover, by the way, that you can't. And so I suppose you can omit life with a phone. You can sort of live without a phone. Try doing that. Even an analog phone reports roughly where you are for E911 services. Now, is that a reasonable balance of services? Yes, it's a reasonable balance of service until you discover that that same information was being, in my view, misused by the federal government to track domestic people in a poorly thought out attempt to track for terrorists. As you know, that program was shut down about 5 years ago. And it was shut down, by the way, for a number of people complained about it, but also because it didn't actually produce any terrorists. So in other words, you can get a situation where even if the instinct is wrong, the outcome is the same. So we want to sort of decide where is the moral boundary and where is the pragmatic boundary. Obviously, if it's a bad idea and it doesn't work, maybe you shouldn't do it. Getting government systems to make those trade-offs turns out to be very, very difficult. So we've got to sort of figure out how we want to deal with protecting and treating data in the United States. And we're sort of following the usual US path, which is that we try one thing and then it's illegal. We try another thing, it doesn't work. And then we try something political and that doesn't work. And we end up with a rough compromise, which most people are okay with and some people fight against. And maybe that's okay. Maybe that's the best way a democracy can get there. But there are differences among democracies, which I'll mention in a minute. So one of the other issues here is that authoritarianism has a lot of appeal for countries, especially when they're dealing with groups of people that are political minorities or even a political majority. And we should be careful to understand that the appeal of I'll just use the word Chinese system for lack of a better word, one which allows for broad surveillance of gait, position, car, face, and so forth, into a big machine learning ID system, which can track and presumably predict where you go, it would be very useful to many other countries, not necessarily democracies. And so the question is, what do we want to do about that? And what I would hope we can do is we can offer an alternative that has a bit more of our values in it to those countries, rather than have them go lock, stock, and barrel to this sort of complete control system, which is very difficult to reform and to get out. It's interesting that we tend to think of autocracy as something which cannot be changed. But in history, there have been examples where kings have turned over to democracies and juntas have given over to democracies. And there have also been examples where democracies have given over to juntas. And so this debate of authority versus decentralization and freedom versus control is not particularly a new one. It's just new in our particular area of technology. And the example that I think is most interesting about privacy is Britain. So if you take a look at the United States, Britain, and Germany, and you ask the average person their view on privacy, in the United States, the consensus is that one should not trust the government, and there's relatively high trust for businesses. And there are some counterexamples to that, but it's generally true in the polling. If you go to Britain, you get exactly the opposite polling data. There's very high trust in the government, its use of data, and there's relatively low trust in businesses, especially foreign ones, especially the tech companies. And in Germany, if you ask people, because of the history of the Stasi and East Germany, they don't trust anything. Now, these are all three very vibrant, very important, very mature democracies that come to very different answers on the same question. And so we tend in America to say there must be one way to solve this problem. Now in Britain, for example, they put cameras, and they have the largest number of street cameras in the world, and they put some limitations on the use of those cameras. It is actually possible to subpoena those cameras if there's some sort of private dispute, and the British people generally support those, and there is a subset of people who fight them all day. When there were a series of demonstrations, there were very, very strong calls to try to use BlackBerry data to figure out who the people were. And indeed, using face recognition, the police, did in fact arrest quite a few of the demonstrators for what was viewed in Britain as an illegal act. So that's where their line is. Where's the line in our country? Where is the line in Germany? Where is the line in China, et cetera? And so my point is that when we have these conversations, we want to understand that these are driven basically, the culture drives the outcome far more than the technology. Put another way, we as technologists know how to make a very tight one or a very loose one or none at all. As you heard in the previous presentation, we understand, for example, differential privacy, and we know exactly how to implement it. We haven't implemented it thoroughly enough, but we do understand how to do it. So when we go back to how we collect data, we basically have to think about collecting data ownership, and what we do with the data. You clearly need consent. You clearly need to be inclusive. You clearly need to deal with sort of the ethics of this. But let me give you a sort of a list of questions. You believe very strongly in your right of privacy. And the major newspapers spend an awful lot of time defending your right of privacy because they are opposed to the government. However, when they decide to investigate you, I'm referring to the newspapers now, they are certainly capable. They're certainly capable of violating your privacy in what they view as their appointed view of letting the public know what you've done in what they believe is evil. And we have plenty of examples in our society around TMZ and Page 6 and so forth and so on. And the system tends to adopt, in America, a more liberal view of this. In the 1980s, there was a terrible murder of a woman whose address had been found because the DMV records had home addresses, and they were made available. So it took a tragedy to change that rule. I'll give you another example, which I hope won't lead to tragedy. There's a technology in airplanes called ADS-B, which publishes the exact location and the tail number of your airplane. And there is a community of people who've taken all of the local receivers and unified them so that you can accurately track by tail number exact airplanes. This includes, by the way, military airplanes, Air Force One, that sort of thing. Furthermore, the design of the system allows it to be hacked and manipulated and so forth and so on. It's a bad system design. So we defaulted to open. And what will happen is this system will stay that way until there's some sort of a tragedy or limitation or a realization that maybe we shouldn't be quite so transparent about people's physical location and especially important assets like the military. It keeps going. Where do I live? What happens with Google Street View? All of that. We fight these things through them. So if I continue, the next question is, who has control over the data? And my personal view has always been that I want people to own the data, and I want people to have control over it. I think that's sort of a stable outcome, but it gets pretty tricky. So there's a fair amount of data that is accumulated in the normal course of your browsing, and you're operating through a network and in the routers and caches and so forth. And people sort of try to criminalize that or at least make it alien, and it doesn't work. So the fact of the matter is, over and over again in my years of dealing with Washington, people will say, well, we want people to have control over that. So do you really want to have control over the cache that's sitting inside of a router, which we don't even know how to identify? Furthermore, how do you deal with the encryption that's inherent in that? So we haven't quite found that balance in all of these things, in the same sense that we have adjudicated for decades these questions about how to manage the balance, search warrants, and public record requests. A good example of how this gets dealt with is something called the right to be forgotten law in Europe. I know this very well because I campaigned against it. Europe decided to pass a law. There was a big debate, and the law was actually promulgated not by the European Commission, but rather by the European Court of Justice. And what they ruled was that for a certain amount of search data, it would be possible for somebody who felt that the information that was inside of search engines like Google, they could challenge it if they were not a public figure, and if it was not of general importance. And they said that the company, in this case Google, had to make these decisions. I argued against this because I thought this was a governmental function, not a Google function, and that Google itself did not have the judgment, if you will, to make a decision as, are you a public person, and are you in fact is this in fact important? That law, called the right to be forgotten, has been functioning, I would say, relatively well for the last 5 or 6 years. The number of removals has been relatively stable. Roughly half, I don't remember the exact numbers, of requests are granted. And there were all sorts of interesting corner cases. So there's a case where somebody committed a crime. They're my next door neighbor. That crime was relatively minor. Their records were expunged. I don't know about it. Where is that line? And we had a series of such examples. So maybe that's a reasonable balance. Maybe it's not. The same rights don't apply to the United States, and they don't arrive, or they only apply to the country versions of those databases. If you think the other next question has to do with using data, and I think the simplest way to think about data is that the collection of data that's going on now, if used properly, can advance healthcare, safety, knowledge, and so forth globally. The key question is with appropriate safeguards. Technologically, we know how to do that. And I would suggest that including healthcare data, that we have a broad research exemption for de-anonymized data done properly, right? So it's not reconstitutable for things like healthcare. If we had done that, we would have been able to do much better healthcare for people, because we all know that most of us are similar to other people. And if we could just take that data and predict outcomes, we could use that to anticipate things that are happening to you and me. As a medical matter, I think this is clear. The problem is that if you actually do something like that, a broad research carve out, if you will, everyone says, well, it won't work, and so forth and so on. So one objective would be for you all to prove that it can be done, and that as a public service matter, we all collectively benefit, as we do for solutions to the pandemic. We all collectively benefit on stronger health. So let me see if I can finish up with sort of a couple basic principles here. I think that one of the things that I learned in doing this now for so many decades is that there will always be opponents to what you're doing. No matter what you do, I used to call these evergreen problems. There's always a community that's worried about privacy, and there's always a community that's worried about security. The question here is not whether you can win them over, but whether you can win the majority of their claims, so that somebody who is trying to do the right thing, balance of interests, and so forth, can adopt them. While I'm annoyed with the European right of privacy, and I think that they made a mistake in doing it extrajudicially and making the company do it, from the European perspective, it seems to have worked for them. So there's an example where wrong mechanism, but perhaps a reasonable outcome for the Europeans. The reason I say it seems to work for them is they haven't changed the law to modify it. And presumably in a democracy, if things are not moving, are not changing enough, and the democracies are working pretty well, they will address these things. So when you all look at data privacy and data ethics, the call would be as follows. First, figure out a way to make sure the data that is collected is encrypted at rest and encrypted in transit. Make sure that you can really warrant to the critics that will always be there that people's privacy is not going to be violated, that no one will be harmed. And harm can be the harm of reputation as well as physical harm. So you've got to be able to convince your opponent, if you will, that you can do that. When I was doing all this at Google, and I'm no longer there, when I was doing all this at Google, we spent a fair amount of time trying to convince people that we were doing something reasonable. And you could disagree with what we were doing, but the principle that I set that worked pretty well is we tried to tell the truth about what we were doing, and then you could judge if the outcome was consistent with what we said, and that built credibility. And then, of course, you can decide if you don't like it. So I think that's a sort of a reasonable compendium of my view, and I'm far more interested in Jeannette's comments, questions, and anything Jeannette has to say. So thank you all, and Jeannette, maybe you'd like to start.
Thank you, Eric. That was terrific. There are so many points that you raised that I would love to comment on, but I would like to first start by telling the audience that Eric and I go back a long way in terms of computer science as a field, including when both of us spent time at Bell Labs when the Unix manual could actually fit in our heads, and at Xerox PARC when the Office of the Future was being invented. giving birth, of course, to much of the success of today's tech industry, including Apple, Google, and Microsoft, and companies such as Amazon that have disrupted many sectors, and companies such as Facebook that have invented new ones. With this historical perspective and your experience running Google as CEO, I'd like to talk about the future of technology, and most importantly, its impact on society. So let's start with that point about technology and society and how technologists should be thinking about societal implications as they make their inventions. For example, I remember in 2013, a powwow with Microsoft tech execs where we said, in 5 years, facial recognition will be a solved problem. Well, for sure, in some sense, technically, it's a solved problem. But the technology has had societal implications. For example, racial and gender bias, that technologists perhaps were too naive to anticipate. And now tech companies are limiting the very use of the technology they invented. So this seems like a conundrum or a puzzle. And that's just face recognition technology. That's one small piece of the applications of AI. So how do you view these implications, benefits and harms of technology in society? What is the social responsibility technologists should have as they innovate?
It's easier if I answer your question with sort of a historic statement that 10 years ago, the way you phrased your question would have been seen as, oh, that's interesting. That's Jeannette. She's from a university. She's very smart. As opposed to the understanding today that the answer to your question is fundamental to the development of these programs. And I can give you example after example after example. In the examples of face recognition 10 years ago, when it was first really coming along, one of our teams, as a part of a development process, built a very useful product, which would basically tell you who was in your field of view. So it would basically do face recognition. It would use the Google image search. It turns out that the estimate at the time was that if there were 14 pictures of you, which most people have on the internet, we could resolve the name using the then existing face technology with higher than 50% accuracy of who you were. I thought this was the niftiest thing ever. It turns out that this product is highly illegal. It's illegal in Europe, and it was illegal in Europe at the time because it was illegal to have private face recognition databases. It appeared at the time to be illegal in at least a few US states. So there's a case where the technology caught and actually got slightly ahead of or I guess I should say the legislators were slightly ahead of the technology when it finally got good enough. And leading probably to a reasonable outcome, unless you're a person who can't remember people's names. But I remember sitting in the meeting and people saying, I don't really think people want to be sort of surveyed and tracked and so forth and so on. And I said, yeah, I agree too. Now think about that today, right? This is again a decade ago, how much quicker everyone would be to latch onto that issue. And there's obviously issues of bias. If you look at face recognition, there's plenty of examples that white male faces are handled much better than the other category of faces in the database because of the way it was trained. And as you pointed out earlier in the sessions, there's this basic problem of training data bias. And most of the training data, it doesn't seem to be broadly representative of the collection and breadth of humanity. So that's another problem to be solved by computer
Do you think
science.
the technology companies were caught off guard, not thinking about the training data as possibly being biased and therefore producing biased models?
There's a difference between being aware of it and having it be the constraining design point of your product. In fairness to the teams that I've worked with, everyone acknowledges your point, Jeannette. It's a question of how important is it. So I'll
but then it does become, I'm quite familiar with this conundrum. If you're in industry, then it in some sense becomes a business decision. The technology, your engineers are familiar or are aware of the problem, and then a higher level conversation happens where the business unit makes a decision.
A better model than that is that as part of the design of the product with the so-called product managers, the product managers bring in the legal and PR concerns fairly early in the design. And today, the way to think about it is, let's imagine that you and I brought out one of these products and we ignored all of these things, which we wouldn't do, but let's imagine that we did that for a thought experiment. The first is there would be a great deal of publicity that would be negative, and the companies try to avoid that. The second is that there would be a lot of negative regulatory concern. These guys, Jeannette and Eric, must be real idiots to have ignored this. Maybe we should go regulate them further because they haven't learned. And there's one more community now that wasn't true 10 years ago, which is the employees. And then our employees would say, this Jeannette and Eric show, these people ignored us. We're going to leak this thing to death. We're going to expose how terrible they are as managers and so forth. So in the system that's occurring now, there are many disincentives that were not as present a decade ago. And that's not necessarily a bad thing.
That's really interesting, and that's perhaps why it's not surprising that these major tech companies are not encouraging or even selling their face recognition technology. So let's move on to a second question. Oh, you want to answer that?
I was going to add, face recognition is a really, really good example because face recognition is essentially a solved problem. And so Here's an example. If you don't like crime, which an awful lot of people don't, then you could illegally in America put in surveillance cameras, put in a large database, track all the criminals, and you would effectively have zero crime except for crimes of passion. Now, I am not altering. So we're very, very clear. I am not advocating for that. I'm simply pointing out that it is technically possible because that's what China did. So what I'm interested in is you get all of these people who give these speeches about the values that they care about. And then you confront them with, okay, I can solve your problem, but it creates these other problems. Can we get a dialogue? Because I think the only way to really address this question, whether it's privacy and security, which are always complicated, is to say, look, I can solve it, but it creates all these other problems.
Yeah. Good. I want to turn to another topic that I know you're very passionate about. It's specifically about AI and data science and the role of government. You have argued for the importance of the US to invest more in AI research and development. What is the role of the US government in these investments, and what are the areas in AI we should be investing in, and why? And why is it important for the US government to be investing more in AI? I think I know some of your answers, but.
Well, I think this is a friendly audience for this argument, but a simple answer is that R&D funding in the United States is now below what it was before Sputnik and the Russia and the Soviet space challenge, which led to quite a rise of funding in science and technology. Part of that rise in funding created the internet and DARPA and all the things that we all know and love. There are plenty of examples of areas where the federal government in particular has funded research at a university level that would not have been funded otherwise. It's the notion of unconstrained research. It's that extraordinary thing about humans where somebody can be sitting in the equivalent of a lab or a chair at home and they can have an idea that's not been had before. Corporations seldom fund such groups. Xerox PARC, where you and I worked, was such an example, but it was relatively rare. Bell Labs, where you and I also worked, was such an example, but it was rare. And Bell Labs, of course, was a part of a structural monopoly at the time, which was given by a judge in the 1930s, I believe, as part of the structure of what was then a monopoly of communications, no longer present. So we are critically dependent as a field and as innovators on the role of the federal government in this. And the new big thing is AI. So I've been leading a commission which has been arguing for additional AI funding for national security in particular. We've been looking at the race, if you will, between the United States and Russia, China, and so forth. We put it in the military context, national security context. And it's the easy way to understand it is we're ahead and they're catching up. And we want to win that race. And the reason we want to win that race is that the next great technology platforms, the next great companies of Apple and Amazon and so forth, the ones that are being founded now, that will be worth trillions of dollars in the future, will all have AI as their base. And so it's just not a good idea to let those companies exist in other countries. We want to win that, and I want America to win. The amount of wealth, creation, jobs, and so forth that flow through the system by these discoveries are incalculably large.
This is a little off script, Eric, but in science, we all also have a naive view that science transcends geopolitical boundaries, and all we really want as scientists is to share the science so that we can build on each other's science and really expedite the advances. Of course, geopolitical concerns do play a role in real life. So, you said, and I want America to win. Is there a worldview where America is not the only number one?
Well, when I say I want America to win, it doesn't mean that everyone else has to lose. I just want us to stay ahead. So I view this as a rivalry partnership where we are, to use China specifically, we work with them when we need to, but we are ahead of them in the things that matter. Now, why does this matter? Well, China has already announced its strategy to win in the areas that I just described. And in particular, in October of last year, before the pandemic, it announced its agenda by 2030 to lead the world in high energy, aerospace, 5G, quantum, AI, software in general, semiconductors, and a number of other categories. So you're naive to think that competition at a national level is not playing a role in this, because through that competition comes at least attempts to counter the American model. Now, there are examples. People will say, well, there are examples where it didn't work. In the early 1980s, Japan, at the height of its both arrogance and sense of role and so forth, created an entire industrial plan around technology which failed. At a similar time in the United States, because of our concerns about largely Japan at the time, America created, after looking at its shortfalls, a group called Sematech in Austin, which appears to have succeeded. So the details matter. But I think, again, if I can just be totally blunt, it's naive to think that science is done in a vacuum. And the current political structures, which are beyond you and me and our audience in terms of our ability to affect them, are going to lead to more of a decoupling of the world, which I generally think is a bad idea. But given that that's going to be occurring, as this decoupling slowly emerges, I want us to be in the strongest possible position as Americans. I think it's better for our nation. I think it's better for our stock market. I think it's better for our tech companies. I think it's better for our students. This has some implications. For example, I'm strongly in favor, and I know you are as well, of allowing the talented foreign students to come to America to get educated, right? So this current bias against foreign students is idiotic. I would much rather have those students come to America and have a good portion of them remain in America and end up founding companies and pay taxes, and I can work for them, which is indeed what happened. Something like half of the Silicon Valley companies are founded by foreign-born sort of scientific types.
Yes, Columbia University very much welcomes and relies on international students for our livelihood. So that's a very welcome statement. Let me turn to a topic that you already mentioned, and it really has to do with the sort of the academic industry government ecosystem. As you know, the Data Science Institute at Columbia is strong in science and technology, but we also take advantage of the strengths of Columbia going beyond science and engineering. We collaborate with all our professional schools, such as in business, public policy, law, and journalism. And many of our audience members run companies, nonprofits, or government agencies. So what is your view on how industry, academia, and government can work together to better balance this tension that you mentioned earlier between these novel state-of-the-art services to individuals and protecting their privacy. And I think the point really, I think you made earlier, is that different countries and different cultures already take different views. So maybe you can speak about the US and what kind of ecosystem balance makes sense for the US in terms of regulation by government, industry innovation, and the role of fundamental research in academia.
I always worry that the politically correct answer to your question is that we have this balance in place from the day we found the company. In other words, we're so brilliant as a founder that we see our tools and our technology, we see all the bias, we see all the impact, we see how it's going to be successful, we understand which lawyers we need to hire, and so forth. The only problem with that is that if we thought about all that as we found the company, we'll never found it. It's not how founders work. And furthermore, constraining yourself in anticipation of future regulation is almost always a suboptimal business strategy. So the reality of how this plays out, again, people may not want to hear it, is that founders push the boundaries. They find the gray spaces and they build something in that gray space. And then they present us with a challenge. And often these founders are, let's say that their strength is greater than their listening abilities. And so they may not themselves understand how close they came through boundaries. If you look at, I'll give you two examples of people who've had an enormous impact on technology. One is Travis, founder of Uber. Another one is Elon, founder of, among other things, Tesla. Look at the things that they did without commenting on the specifics to build what are large and important companies in our daily lives, right? Think about, are you able as an individual to have done all of that? Should you have done that, et cetera? And that's a debate that's a very rich one. But part of the genius of our systems is that the founders are more likely to run ahead of everybody and create problems. Now, I have a second view, which is I don't like preemptory regulation. And the reason is that it's very easy for regulators to anticipate harm before it's occurred. So I'll give you an example. Every year, there's a group of people that believes that we should begin to regulate the misuse of AI. And what they're referring to is when the AI is smart enough to begin to harm humans. And they have various ideas of how to do this. And since we're not quite at the point where the AI is doing that, it's probably better off for us to wait until we see how the technology actually plays out and instead focus on things like bias and the other things that you're focused on, which we do understand. So writing down a theoretical scenario, like the robot, it's always the same, right? It's a brilliant female robot that is created by a male who then kills, the female robot then kills the male inventor, right? That's what the movie is all about. Well, I'm pleased to report that we're not anywhere near that scenario in AI. And so we don't need to regulate that scenario yet. And furthermore, since we're all anticipating it, when it does actually occur, we'll know that it happens. And people will notice that the robot has become so dangerous like in the movies. So the point of being facetious here is to say that premature regulation for something that has not happened yet has secondary effects in the design of the system that can really hobble it. And so I always like to say a typical group to criticize here would be the European Union. They're extremely good at writing future regulations for things that have not yet happened. And I'd much rather have them regulate the things that have happened. And they say, well, we have to get ahead of it. Well, I'd much rather have a flexible regulatory structure that can move quickly based on the reality in front of it as opposed to the anticipated future.
I think another part of the solution in your world, I think, would be where you have, as you suggested earlier, more people on your engineering team or in the bigger project team that understand the societal aspects of a given technology and the conversation starts earlier. So on your design team, you start thinking about issues of ethics and privacy and fairness and so on. And I think that is actually perhaps new in terms of structuring an engineering team in a tech company.
And every computer science department now has the equivalent of a computer science ethics program where these issues are being debated. I wrote down a set of questions, which I don't know the answer to, which I'll just offer out for discussion. One is how compatible are democracy and social media, given the tribalism? Is it possible to do deterrence in the sense that we can do nuclear deterrence? Can we do that in software? Is there a rule-based way to organize a software system so the parties that don't trust each other are held together? This is sort of the Bitcoin question, but I'm not asking a Bitcoin question. What do we do about broad-scale misinformation and manipulation of these things? Can we build an engineer's version of American exceptionalism that's consistent? Right. So these are I think the really hard questions. How do we make sure that democracy eventually wins in the fight between autocracy and democracy? Right. So if you can imbue those questions, right, and they are in fact balance of power, ethics, and technology design questions. I don't know the answer to these questions, by the way. I'm asking them rhetorically, and maybe there are others that I have missed. We know the answer to face recognition, which is it is better than humans, and that we have to restrict it for that reason. What's the answer for the next set of technologies?
Let me ask you a question. Again, this is off script, Eric, but you're very good at this. What's the biggest surprise you've had from a technology perspective, say in the past 5 years, looking forward in terms of the impact on society? I have an answer to this question. It's not probably what you would.
So for me, it's easier if I again give you a narrative. I was absolutely convinced that voice would never work, and of course I was wrong. I was very convinced that voice communication between computers would not work. I was wrong, and I was absolutely convinced that there would not be any significant social impact from social media because of the filtering and tribalism issues, and I was wrong. So I have a long history of being wrong.
So your surprises were things that you didn't think would happen, but happened. Yeah. Actually, you already brought up the topic which surprised me the most, which is I don't think we in the technology community anticipated the ease at which information could be falsified and thus disseminated. And it's not just about a technology solution now. It's really about addressing human cognition and how information reaches one's brain in processing the information that one can get so easily now. I think we in the technology community did not anticipate fake news in the way that it has really blossomed and now threatens democracy.
Very well said. And what's interesting is that when you compare the tech industry and politicians, which I spend a lot of time doing, politicians spend most of their time saying the same thing over and over again as quickly as possible. And there's a race to get on television before anyone else. And I always assumed that that was just vanity. But in fact, it's the correct strategy because of anchoring bias, where what happens is that people who don't know something, the first time they hear something that's plausible, such as from a politician, they believe that and they judge everything from that. So what we're seeing, in broadly speaking, in the information and social media space is we're seeing all of the human biases, which are just a human thing. They pre-exist you and me, being used at scale. And people are fearful. People don't necessarily know. People want reassurance and so forth. So going back to this question of how do you keep democracy and social media compatible? And how do you deal with this question about fakes is a key one. I have one idea that I've been proposing for quite some time is that all information have on it a timestamp, which is presumably maintained in the equivalent of a blockchain, which shows its point of origin. So at a minimum, it would be possible to go back and see the origin of the information. So when somebody sends me something which is probably not true, I always try to figure out what the origin is. And the origin is always entertaining. There was a false rumor about something involving COVID in Florida. And so I spent some time trying to figure out who the author of it was. And it was a Mr. So-and-so who was, by his own testimony, assuming he was a person, an engineer in Orlando who was the world's expert. Of course, he had no background in this, in the testing regimes and statistical modeling of the testing in COVID. And he wrote a very lengthy diatribe, which was completely false, completely sounded plausible to somebody who was not a scientist. And why he did this is beyond me, assuming it's a real person. But we don't know if it's a real person. We don't know what his motivation is. We certainly know his facts were false. And that, running that exercise for 1 million times, especially in an election season, is just very difficult.
Okay, Eric, there's some questions from the audience. I'll read this first one. Should individuals be paid for their data? If yes, how should remuneration be determined? Or should monetization of private data be abolished?
So this question has been around as long as advertising-based systems exist. And I would argue that you are being paid for your data in the form of having free Google search. Right. In other words, that the data that is collected, which is regulated in terms of its use as well as the length of time it's maintained, there are restrictions on its use, but fundamentally you're getting a free service for it. If you start to charge for the data, and people have proposed these sorts of things, then many free services will stop, which is an okay decision, but not a decision that's going to be popular.
Any other questions from the audience? Okay, here's one. What are your thoughts on the environmental impacts of data? How is the technology industry and our government considering the energy and material resources to service our data-hungry world? I know you have a very strong interest in climate and the environment, so this is quite relevant.
So in case anyone is confused, climate change is real. And if you're confused, spend a little time in San Francisco last week and look at the orange sky, all of which is related to temperatures and so forth. Look at the rate of hurricanes in the Caribbean and these sorts of things. I spent some time in Antarctica, and the rate at which the western ice sheet, Antarctic ice sheet, is melting is of great concern to will be of great concern to your grandchildren. It's happening far quicker, and of course that flooding that is going to be profound compared to what we've seen today. So climate change is very real, and we need to address it. Given our inability to deal with the pandemic, which is a relatively mild challenge compared to climate change, I'm not particularly hopeful at the moment that collectively we're going to address the issues of climate change. But let's start with the fact that the pandemic is real and climate change is real. The tech industry got on the data center and environmental cost stuff very early. And in 2004 or so, Google, and I know this because I did it, announced that we would be net zero. In other words, that our data center generated, we would offset in one thing or the other. And it turns out that environmental efficiency is also good business, because reducing the amount of energy use also saves money, smaller footprint and that sort of thing. So there is concern that the explosion in the cloud computing and data servers is such that it will have an aggregate impact globally in terms of energy usage. However, I can tell you that by comparison to the other issues in other industries, it's still relatively minor. So if you want to work on something hard, work on the question of steel and concrete and their compound contribution to carbon loading, which is an unsolved problem at scale. There are many, many harder problems, and I would focus on them.
Thank you, Eric. Any last question? One more question. Eric, you started your talk on China's current control of data and how that interacts with its government. What would you suggest that the machine learning community do to ensure its technology not fall into wrong hands or use cases?
It looks to me like the cat is out of the bag, or whatever metaphor you want to use. The China's AI stack is well developed, and in areas like face recognition and surveillance technologies, my assessment is China is 1 or 2 generations ahead of the rest of the world. You could be sure that they used open source data to start with, but you can be more sure that they have now private firms. China has a model called civil military fusion, where there's not much distinction between the companies and the way the military works in China. It's a different model than the United States. And in that, you have to assume that the leading companies, which are national champions, have military national security components where they're doing hard and what is important work in China to serve that customers. I obviously don't agree with it, but I think the reality is there's not much we can do. There are going to be inventions. I'll give you an example. Let's imagine that at Columbia, we have, so I'll give you 2 examples. OpenAI invented something called GPT-2, and it withheld the actual code base of GPT-2 for about 3 months or so, 3 to 6 months, I can't remember, because it was concerned that the technology might be misused. It ultimately released that technology and has more recently done something called GPT-3, which it broadly released. So as far as I know, OpenAI was the first example of a company that would have released open source and that withheld it for a while. I think we really need to establish some principles of how to do that going forward. And eventually, my guess is there will be regulations in this area. So Columbia invents a genuine breakthrough in artificial general intelligence. It's a dual-use technology. It could have enormous implications for national security. How would Columbia deal with this? Well, Columbia is a university. It's committed to open source. You would publish it. Is that the right answer? I'm not suggesting I know, but I'm suggesting that you should frame the question that way.
It's a good point. Eric, thank you so much for your time. This has been a wonderful discussion. It's good to see you again, and good luck to all of your new passionate interests.
Okay. Thank you very much, and thank you all for doing this.
Thank you, Eric. With that, I would like to thank Eric, Yeon-Koo, Roxana, Jeff, Rafa, and Tamar for their participation in today's event. I'd also like to thank, again, our industry affiliates, and to thank our stellar DSI team members for bringing everyone together, especially Alexis, Peter, Sharon, Jessica, and Ralph. Finally, thank you all for attending today's event and for your continued support of DSI as we advance the state of the art in data science, transform all fields, professions, and sectors through the application of data science, and ensure the responsible use of data to benefit society. Hence, DSI's motto, Data for Good. Please save the date for Data Science Day 2021 on Wednesday, April 21st. Registration is open at datascienceday.net. Thanks again, everyone. Be safe and be well.